This is the brief on transient heat conduction. The concept that explains why the inside of an object always lags behind its surface temperature. So we're diving into a couple of sources that explore a fundamental question in thermodynamics. What actually happens inside a metal sphere the instant you plunge it into a superhot oil bath? First, let's talk about the ideal thermal boundary condition. If that sphere is dropped into an efficient oil bath, its outside surface instantly matches the oil's temperature. That immediate adaptation right at the surface is the critical starting point for analyzing the whole object. But, and here's our second key point, the inside doesn't respond at the same time. Not at all. Transient heat conduction analysis shows that the temperature change is really just localized at the boundary at first. For a good while, the sphere's core is basically thermally isolated. Finally, the rate of all this is governed by the Fourier number. Think of this as a sort of critical timer. It dictates exactly how quickly heat penetrates relative to the sphere's size. This just confirms that heat transfer is a slow, diffusive process. The object only reaches a uniform temperature once this number gets high enough. So really, getting the difference between the instant surface condition and that lagged, Fourier number-driven internal diffusion is fundamental to understanding how heat actually flows over time.